Saddletech Military Systems presents Scientific Pack Transportation, a comprehensive scientific solution.
Now we come to about the most important thing you men will have to learn, the adjustment of a new pack saddle. Bring in that new saddle we picked up. You see, each saddle you put on a horse has to be adjusted to that particular horse's back, and it can't be used on any other horse without complete readjustment. Now, the fit of a saddle is as important to a horse as the fit of a shoe is to a soldier. These pack saddles are made so that very little adjustments are necessary on the normal horse. However, this weight-bearing surface of the saddle has to conform perfectly with this, the weight-bearing surface of the horse's back. Is that clear?
Saddletech Military Systems provides a wide array of state-of-the-art products. By way of introduction, our company was founded 20 years ago by building the world's first computer saddle fitting system, which was a way to actually measure the pressures under the saddle. This is a computer pressure sensor pad that we originally developed for measuring pressures on humans in hospital beds. This technology permits us to actually see a color representation of the pressure on the horse's back. Now, expert saddle fitters claim that you need to fit the saddle so it fits evenly on the horse's back. Now, to test that theory, we have molded a piece of plastic into a mirror image of this horse's back. Since the plastic is clear, we can actually see that it fits this horse perfectly. Okay, so now what we're going to do is put the plastic to test this idea if an even surface actually does what everybody says it does. So we've got that with a little bit of padding for the horse.
Yeah, Robert,
Okay.
I'm seeing a
Now
lot
you
of
see what's happened here?
red.
You've got a space in the middle here, and then you've got pressure top and bottom. That's called bridging.
Okay.
That's how you get the white hairs on the horse.
But what's interesting is that was the one with equal distribution.
You
So
got it. You got it. That's the issue.
It's not
That's the
working.
issue, that what you've been told for all these years is false.
So it doesn't matter if the saddle weight is evenly distributed, because when the rider gets in the saddle, it all changes.
Exactly.
Right? Develop this system?
Yeah.
The computer system revealed that very few saddles actually fit, and we quickly understood that the saddle industry actually had no way to determine the three-dimensional shape of the animal, much less the three-dimensional shape of the saddle. So we invented the Saddletech gauge. These two animal and saddle measurement systems permitted us to apply the scientific method to saddle fitting. Measure, hypothesis, predict, test, and validate. The three-dimensional measurement system then permitted us to develop a calibrated manufacturing process to make thermoplastic animal back protection devices. The animal back protection device is basically a thermoplastic sheet draped over a calibrated adjustable jig, which itself is built on top of the Saddletech animal measurement gauge, which permits us to be able to manufacture calibrated thermoplastic orthotics of any shape to correct for defective saddles. Ironically, our newest product is a modular animal mobility platform that does not require measurement to fit the saddle, because we developed a beam that conforms to the shape of the animal's back. This is basically a plastic beam and leaf spring that can be made to bend very precisely, so that no measurement or fitting is required. This is plug-and-play technology. What is even more amazing is that we can actually prove that it works, loaded with 200 pounds, by employing the computer saddle interface pressure measurement system that we also invented. For the skeptics in the audience, this is the system with a 350-pound load. Now, this is just a prototype, so there is room for improvement, but it does make the point at 350 pounds, it works pretty well. We then put D-rings and cleats all over the place, so no knots were required. Then all sorts of different cargo can be loaded onto the pack frame: weapons, packs, water, ammo, with no fitting, no knots, or training required. Basically, we out-invented ourselves. So fasten your seatbelts, and here is the story of how we did it.
All forms of transportation are required in the military service. Pack transportation, the means of transporting loads on the backs of pack animals, is of the greatest importance in campaign. The light Phillips pack saddle is used for the cavalry to transport machine guns, ammunition, rations, medical kits, and all other equipment required in the field.
The history of the MAMP pack saddle traces back to World War I, when the United States Army had a desperate need for a simple pack saddle that was easy to use, packed quickly, and could accompany the cavalry at all gates. This challenge motivated the military to test nearly every pack saddle of the time, including many of the pack saddles that SOF currently employs. This research culminated with the Phillips pack saddle being adopted for the cavalry service in 1924. The Phillips pack saddle served meritoriously in World War II in the Burma campaign with Merrill's Marauders, who became the United States Army Rangers, and in the Italian campaign during World War II with the 10th Mountain Division, who are today serving in the mountains of Afghanistan. The Phillips pack saddle is undoubtedly the most advanced pack saddle ever developed until today. Unfortunately, the Phillips pack saddle is no longer manufactured. Fortunately, the MAMP Modular Animal Mobility Platform has just been developed to replace the Phillips pack saddle and permits the tactics, techniques, and procedures developed by the Army 100 years ago to be reintegrated onto the modern battlefield with the proper equipment. The Modular Animal Mobility Platform is the proud successor to the Phillips pack saddle, offering all of the superior features of its predecessor. However, what makes the MAMP pack saddle totally revolutionary is the use of computer-aided design and finite element analysis to create a calibrated load beam and curved leaf spring that self-adjusts to the animal and requires no measurement to be able to fit the saddle. Now, by employing the computer interface pressure measurement instrument, one can validate that a 150-pound load actually exerts pressures that are below a half a pound per square inch. No wild guesswork here. This is the real deal. Now, this is a series of saddle interface pressure measurements starting at 150 pounds. Now, 200 pounds, 250 pounds, 300 pounds, and finally 350 pounds. Now, this is a prototype system and will improve with the next generation. However, that said, comparing the 150-pound load to even a load as high as 350 pounds does prove the point that the MAMP saddle still does distribute the pressure relatively evenly at more than double the load, which is well beyond the load that should ever be placed on any animal. Now, it is all well and good not to overload the animal. However, if we go back 100 years to the manual of pack transportation, sometimes in an emergency you have to overload the animal to save lives. Now, this is an example right out of the manual of transporting 2 injured soldiers who can easily exceed 350 pounds. The fact that the prototype MAMP system can sustain such loads as high as 350 pounds has utility on the modern battlefield. After learning how to fit the saddle to the animal, one of the most difficult challenges in pack transportation is learning the knots. One of the significant features of the MAMP system is that it does not require any knots to be learned, because the pack saddle has cleats and D-rings all over the place. The basic MAMP pack saddle has immediate utility for the SOF Warrior program to reduce the load and improve the performance of the operator. because the operator does not need to know how to fit the saddle to the animal, nor do they have to learn any knots. By shifting the pack load from the operator to the pack animal, the operator could save their strength for the mission. The MAMP pack saddle could be precision dropped from any aircraft with supplies. The operator on the ground need only find any sort of pack animal and place the backpacks on the MAMP system and tie the packs to the saddle using the cleats. No knots required. A simple solution. Another unique feature of the MAMP saddle is that it creates a solid base upon which a variety of different hangers and cargo systems can be employed by using a side support. The MAMP system even has a quick-release cinch. That is actually a modern redesign of the cinch that was developed for the Phillips pack saddle. We just added a cam to provide greater leverage and made it easier to use. SOF employs legacy design sawbucks and Decker saddles because they're the only saddles that are currently manufactured. The MAMP system can be converted to legacy sawbuck and Decker packing methods, affording all of the advantages of the MAMP pack frame, permitting packers who are familiar with the Decker and sawbuck loads to migrate to a more modern system, which is healthier for the animal. Retrofitting legacy designs is one alternative. However, an even better idea is to use the wide variety of alternative modern packing strategies offered by the MAMP system. One basic configuration provided by the MAMP system is a flatbed, just like a flatbed truck. This platform permits anyone to move virtually anything. With cleats placed all over the place, any odd shape can be secured to the flatbed without the use of knots. The modular design of the MAMP system also permits a stake bed, like a stake bed truck, to be added to the MAMP flatbed. Here is an example of a current SOF missile transport system right out of the latest 2004 field manual. This legacy design requires the use of ropes and knots and forces the animal to move slowly so that the missiles do not become loose. More significantly, because the missiles actually touch the animal in the front and the back, there is a chance the animal could be injured and the mission aborted. In contrast, this is a MAMP system shoulder-fired missile rack or a 50 caliber machine gun rack that can be secured to the MAMP stake bed with simple hitch pins so that the hanger can be converted to carry a wide variety of weapon systems. Note the quick release system that could be adjusted to any tension. This feature could permit a wide variety of weapons to be moved into the field and have quick release capability. Backpacks, flatbeds, and missiles all can easily be packed without the use of knots. The next important task is carrying water or fuel. The MAMP stake bed can carry water, either 20-liter jugs, many little half-liter water bottles, again without the use of knots. Now, to feed the 50 caliber machine guns in the quick release rack, the MAMP system can also carry 100-round ammunition boxes. Even a combination of water, fuel, and ammunition can be carried with this system. The MAMP system does not require knots because there are cleats conveniently placed all over the place. The MAMP system is significantly different from all other pack saddles because no fitting is required. Because of a revolutionary calibrated load beam and leaf spring array that self-adjusts to the shape of a wide variety of animal backs. This revolutionary design can be used virtually right out of the box, so no training is required, permitting any operator to reduce the load and improve the performance by just transferring the heavy load to the pack animal and be able to save their strength for the mission, providing a combat multiplier. Now, here is the challenge. This is the 2004 Field Manual, Special Forces Use of Pack Animals. In Section 531, Fitting and Adjusting the Saddle, the manual correctly states, improper adjustment may cause injury to the animal or may affect the time and distance the animal can carry its load. However, And neither this field manual or its predecessor or any of the field manuals that the Army has released does it actually explain how to fit the saddle to the animal. Because the military does not have any method of measurement to be able to fit the saddle, and even if they did have such a system, most of the saddles that SOF currently employs have limited adjustability or are not adjustable at all. Even worse, today SOF has to rely on the United States recreational saddle industry for pack saddles because nothing else is available. This is a mission-critical skill set with no solution. This is an unacceptable position. No method of animal and saddle measurement, and the saddles are not adjustable.
Let me tell you something. No matter how many planes and tanks and guns you pile up, no matter how many men you got, doesn't mean a thing unless the men get the stuff when they need it.
Well, the idea for coming here for the pack animal training is there's areas in Afghanistan where you can't reach by helicopter or by roadside for resupply. So helicopters have ceilings, soldiers' backs hurt a lot of times from carrying too heavy of loads, and so this is a great opportunity to move equipment and logistics to areas we couldn't normally move.
Today, the United States military has battlefield supremacy on land, at sea, and in the air, with one exception: mountains and jungles. Whatever else he may be, Osama bin Laden is a horseman, and so are many al-Qaeda members. Bin Laden has proven that engaging special forces in mountainous terrain places the United States military at a technological disadvantage. The Modular Animal Mobility Platform will permit a shift in the balance of power back to the United States military in mountainous regions of the world where many terrorists seek refuge. By permitting virtually any soldier to use any old pack animal and avail themselves of a combat multiplier because no fitting, no knots, or training is required, so that anyone can move virtually anything, anywhere, anytime, by pack animal. Saddletech Military Systems can provide a comprehensive scientific solution to pack transportation with animal and saddle measurement, animal back protection, as well as a modular animal mobility platform. Thank you for your attention to this presentation, and happy trails.